Hi student, welcome to my channel Education Shop. In this video we solve example 11.8 from the book Heat and Mass Transfer Essential 6th edition. Here this statement is related about the Effectiveness-NTU method. Statement say a counter flow double pipe heat exchanger. This is counter flow double pipe heat exchanger is to heat water from 20 centigrade to 80 centigrade at a rate of 1.2 kg per second. You can see in the figure the water is in this tube and then out at a temperatures of 20 centigrade and in at 20 centigrade, and the mass flow rate of the cooled water is 1.2 kg per second. The heating is to be accomplished by geothermal. Water available at is entered at the shell side, that is 160 centigrade, and its mass flow rate is 2 kg per second. The inner tube is thin walled and has a diameter of 1.5 centimeter. The inside diameter is also given, that is 1.5 centimeter. The overall heat transfer coefficient of the heat exchanger is 640 watt per meter square dot Kelvin. Using the Effectiveness-NTU method, determine the length of the heat exchanger required to achieve the desired heating. By using the Effectiveness-NTU method, we will find the length of the heat exchanger that can achieve the desired heating. When it says using the Effectiveness-NTU method, then your focus must be table 11.5, and for this type it's a counter flow double pipe. That's why we can use this formula and this based on the capacity ratio. If capacity ratio comes less than 1, then we will use this formula. If capacity ratio becomes equal to 1, then we will use this formula in order to find the NTU value. But then this NTU value that we calculated from this formula will further use to find the surface area. Let me write first the given data. The inside diameter of the tube is 1.5 centimeter. In other words, 1.5 multiplied 10 to the power minus 2 meter. The hot temperature in is 160 centigrade. The hot temperature out here is not given. The cool temperature in is 20 centigrade. Remember, the mass flow rate of the hot fluid is also given, that is 2 kg per second. The cool temperature out is 80 centigrade and the mass flow rate of the cooled fluid is 1.2 kg per second. The overall heat transfer coefficient is 640 watt per meter square dot Kelvin. You need to find the length of the heat exchanger. Now come toward its solution. First we will find the capacity rate of both the hot and cool fluid. The capacity rate of the hot fluid is equal to m dot h, and the CP value for this hot geothermal brine fluid is 4.31 kilojoule per kg Kelvin. These are constant and will be provided in the exam. So you can say that's 2 multiply 4.31 and it will give you the heat capacity for the hot fluid 8.62 kilowatt per Kelvin. Now the capacity rate of heat capacity for the cooled fluid m dot c, and the CP value of the cooled fluid, that is water, 1.2 multiply for water 4.18. Simply multiply and you will get 5.02 kilowatt per Kelvin. Here if you see that the C minimum who have less capacity rate, here you can see that the cooled fluid is C minimum and its value is 5.02 kilowatt per Kelvin, and C maximum is that one who have high capacity rate, and that is CH, and is 8.62 kilowatt per Kelvin. Then the capacity ratio is equal to, here you can see from this table also, C minimum divided by C maximum. What is C minimum? That is 5.02, where C maximum, that is 8.62. Just simply solve and you will get the capacity ratio, that is 0.582. Next is to find the maximum possible heat transfer rate, that is Q dot max, and it is equal to C minimum and the maximum temperature difference in the heat exchanger, that is T hot in minus T cooled in, that is C minimum 5.02 into T hot in 160 minus T cooled in, that is 20. Just simply multiply and you will get Q dot max, that is 702.8 kilowatt. This is the maximum possible heat transfer in the heat exchanger. Now the actual heat transfer in the heat exchanger is equal to Q dot, and it is equal to capacity rate of the cooled fluid and change in temperatures of the cooled fluid, that is T cooled out minus T cooled in. The CC value is 5.02 and cooled out temperature is 80 minus cool temperature in is 20. Simply multiply and you will get the actual heat transfer rate in the heat exchanger, that is 301 kilowatt. Next is to find find the effectiveness of heat exchanger, that is actual heat transfer divided by maximum possible heat transfer in the heat exchanger. Q dot is 301 divided Q dot max, that is 702.8. Just simply do this division on calculators and it will give you the effectiveness of heat exchanger, that is 0.425. You see that from this table 11.5 the value of C is less than 1, so you will use this formula in order to find the NTU value, and we have also calculated the effectiveness of heat exchanger. I'm writing this formula on the notebook and just plug in the corresponding values. NTU is equal to 1 divided by C minus 1 ln effectiveness of heat exchanger 1 divided by effectiveness of heat exchanger capacity ratio minus 1 ln effectiveness of heat exchanger 0.425 minus 1 0.425 0.582 minus 1. Simply solve this on calculators and it will give you the NTU value, and that is, let me solve on calculator. This is equal button and it will give you the NTU value, that is 0.65 almost. Let me write on the notebook. Also, you know that NTU is equal to U surface area divided by C minimum. NTU is equal to surface area U divided by C minimum. Here we are interested to find the surface area. We will multiply both sides with C minimum and divide with U. This will cancel out with this. This will cancel out with this, and the surface area become equal to C minimum value of NTU divided by overall heat transfer coefficient, that is given. C minimum is 5.02, NTU value is 0.65, and overall heat transfer coefficient is 640. Just solve this on calculator and it will give you the surface area, that is 5.11 meter square. And we also know that the surface area is equal to pi dl. We are interested to find the length of the heat exchanger. Surface area is 5.11, pi is constant, and inside diameter of the pipe is also given, that is 1.5 multiplied 10 to the power minus 2. Length we required, that is divide both sides by pi, and 1.5 multiplied 10 to the power minus 2. This will cancel out and solve this on calculator. You will get the length of the heat exchanger, that is almost 108 meters. We also solved this example 11.8 in example 11.4, but that was solved on different method, and it is solved on the NTU Effectiveness-NTU method, and it gave more practical approach as compared to the previous one. The links of the video is in the description. Please watch that also. Thank you so much.